Okay, I got a request to make a review video for our gas laws test, which is coming up either later today or tomorrow, or maybe Thursday, if you're going to be gone tomorrow. Anyway, too much talking. All right, so here we go. Just a quick review. The ideal gas law includes all four variables: pressure, volume, amount, or number of moles, and temperature. And I set it up this way. Most people write it as PV equals nRT, but I like it PV over NT equals R, because you can see all the other gas laws involved in that equation. Notice the P1, V1, P2, V2. That's the P's and V's in the numerator. Volume and temperature. Volume is on top, temperature is on the bottom. Pressure and temperature. Pressure is on top, temperature is on the bottom. See how this is working out for us? Volume and amount, V on top and on the bottom. And then if we include three of the four, right, there's the combined law, that's what they call that, P and V on top, T on the bottom. And then if there are all four, then we just use the ideal law. I don't care whether you know the names of the laws. If somebody's watching this from some other school or with some other teacher, they might want you to know the names of the laws. I personally don't care whether you know that or not. Sorry, Jacques Charles, Robert Boyle, Avogadro, all those guys. Don't care. So when you're using any of these, like for example, if you're using Gay-Lussac's law, you just assume that the amount N and the volume V are constant. Sometimes if you're reading or using a professionally made question, they'll say that in there, N and V are constant. So we'll just assume that if it doesn't say otherwise. And notice if you're using one of these laws, in the problem you're going to have two volumes or two pressures or two temperatures or two amounts or something like that. So just be aware of that. Okay, so let's get on with the problems. A gas with the pressure of 650 torr has a volume of 100 liters when the temperature is 50 Celsius. At what temperature will the pressure be 750 torr and the volume be 110 liters? So we're seeing two of many things here. Two of many things. Like we got two pressures, two volumes, two temperatures. We got a pressure of 650 torr. A volume of 100, oh, why is that V2? A volume of 100 liters. A temperature of 50 degrees Celsius. If we add 273 to that, we'll get 323 kelvins. Second pressure is 750 torr. A decimal there. Volume 2 is 110 liters. And the T2 is what we don't know. So we've just read the problem, made a list of all the things that we know from the problem. Good thing to do. Very good thing to do. You might get a point for that at some point. All right, so let's take a look at how we can solve this problem. We put the P's and V's on top and the T's on the bottom. And you could certainly plug in here and solve for T2. Or you might rearrange to solve for T2 first. And then plug in. Doesn't matter to me how you do it. Whatever you're the most comfortable with. You could plug in here, cross multiply, whatever you got to do. Whatever you got to do. So why don't you pause the video at this point and see, well, and go ahead and plug in the things, and then you can start the video back up, and you can check to see if you got them right in the right places, and then you can pause again, and we'll solve the problem, and then I'll give you what my answer is. So go ahead and pause at this point. Go ahead, pause. You should pause now. Go ahead and pause. Okay, I assumed you're paused. So here's the way I plugged it in using the equation on the left and cross multiplying. And so then my T2 will be 750 torr, milliliters, 323 K over 650 torr, 100 liters. If you want to pause there for a second while you solve the problem, keep solving, and then so I got for T2 409.96 Kelvin, which I would probably round to 410 with a decimal point, just to keep everything with 3 digits, because we started with 3 digits. We should end with 3 digits. If you got, for example, 0.002439, let's write that on there, 0.002439.262. You did the problem upside down. You solved for 1 over T2, not T2. Just saying. So if you ever get a number like that for Kelvin, you've probably done something wrong. No, not probably. You have definitely done something wrong. I will not plug into this one and solve it. If you want to do that yourself, just to see if you like it better that way, you should get the same answer, 410 Kelvin. All right, let's move on to the next problem. 10.25 grams of ammonia gas has a pressure of 125 kPa at a temperature of 0 Celsius. What is the volume of the gas? Do I have another page? I do not. So we had to do it all in here. So I've got 10.25 grams of ammonia. I've got pressure is 125 kPa. I have a temperature of 0 degrees Celsius plus 273 would be 273 Kelvin. I'm looking for the volume. I can always know R. Since we've only got one of everything, we're going to be using PV equals nRT. So R using kPa, 8.31 liter kPa per mole Kelvin. And the only thing we don't have that we still need is N, which is amount or number of moles. Now we do have, though, a mass of the gas. So if we have the mass of the gas, we want moles of the gas. We divide by the molar mass. 1 mole NH3 over 17.04 grams of NH3. And that should end up being 0.602 moles. So I am looking for volume. So here's my equation. I need to move the P from the top on the left to the bottom on the right. V equals nRT over P. Oops, I got too rambunctious with my fracto. That's what I call this line between the numerator and the denominator. I call it a fracto. I made that up. So if you feel like using it, spread the word. It's a fracto in my mind. Maybe I can get credit for it. Anyway, plug into that equation, solve for V. I will let you pause at this point while you do that. Are you paused? Go ahead and pause. Okay, you've unpaused, I assume that you paused and you worked it out. You plugged in. You should have gotten that V was 0.602 moles times 8.31 liter kPa per mole Kelvin, and T is 273 Kelvin. Sorry, I ran out of room. Over P, 125 kPa. So if you want to pause, make sure you had those all in the right place. Then if you want to pause while you solve, well, I'll pause the video so you can solve the problem. If you paused and now you're not paused anymore, I hope you got 10.9 liters. So hopefully this will help you as you prepare for the test. There could be a gas stoichiometry, but that's just stoichiometry and a gas law problem combined together, and you already know stoichiometry because we've tested over that a couple times now. And so you just have to plug things in where they go. House equation, get moles, times find over given, and then do whatever it takes to finish the problem. So we will let it go there. Good luck.